Okay, 7.5. We're flying through probability and trying to get it finished. Okay, probability involving permutations and combinations. So back in the first book, we would have done permutations and combinations and the difference between them. So permutations, the order sort of matters. So how many passwords are possible with these letters, where it matters the order of them. Where combinations, it's like how many pupils can I choose from a class, how many different ways can I choose 2 items from 5. It doesn't really matter the order. And we're going to do a couple of problems. It says you can use them to find out the number of ways. So permutations and combinations find the amount of ways something can happen, and then we can apply that to the probabilities. So we're going to do 2 examples. The first example I'm going to do similar to the way the book has it. The second example, they use combinations to do it. I'm going to do that a bit differently, and you'll have 2 ways of looking at it then. Okay, you can choose whichever way you want then. Alright, so example 1. It says, in class 6A, 2 boys and 4 girls study music. In class B, 4 boys and 6 girls study music. There we go, I've written down there. 2 pupils chosen from each class. 2 pupils are chosen at random from each of the 2 classes to perform a concert. In how many ways can the 4 pupils be selected? So they're given some things that we have to follow, and one of them is that there has to be 2 from each class. So it's not a case that there's 1, 2, 6, 16 altogether, and you're just picking 4 people. You're picking 2 from the first class and 2 from the second class. So how many different ways is there of doing that? Okay, so in class A, there are a total of 6 people, and we want to choose 2. So there is 6C2 ways of doing that, because there are 6 pupils, we want to pick 2, you could pick the first 2, you could pick the first and the third one, so there's all these different combinations, and that's how we do it in a calculator. 6C2 times. The second one, there's 10, and we want to again choose 2, so there's 10 pupils and we want to choose 2. And again, the way we do that in our calculator, remember 6 shift C2 equals 15 multiplied by 10 shift C2 is 45 times by 15, 675. Okay, that's the first one done. So there's 675 ways of picking those 4 pupils if 2 of them have to be from 6A and 2 of them have to be from 6B. Okay, it has to be 2 boys from 6A and 2 girls from 6B. So in 6A, we're choosing the 2 boys. So it's 2, there's only 2 boys and we're taking both of them. So you'll see there's only one way of taking that, and 2C2 is 1. I'll show you on the calculator in a second. And in the second way, we have 6 girls and we want to choose 2 of them, so it's 6C2. So there's more limitations on us here. So if you see 2 shift C2 will be 1. And we know that because if you have 2 boys in a class and you're taking both of them, there's only one way of doing that. There's no other combinations you can do. And then 6 shift C2 is 15. So there's 15 ways. 675 ways. Okay, that's all they ask. They ask how many ways is there of doing this. The third one asks about the probability of the same gender. Okay, the probability of the same gender. Okay, so there's 2 ways of doing that. Let's start with girls first. 2 girls from 6A and 2 from 6B. Or, like they say, it could be 2 boys from 6A and 2 boys from 6B. Because they say at the start the 2 pupils chosen from each class. So we're still going under that, guys. The 2 have to be chosen from each class. We can't just pick them from anywhere. Alright, so I'm just going to, so 2 girls from 6A and 2 girls from 6B. So the number of ways those girls can be chosen. So we'll just do A first of all. It's going to be from, remember, going back, I'll have to just look up there just to remind myself how many. So in 6A there's 4 girls and we want to choose 2 of them, And in 6B, there's 6 girls, and we want to choose 2 of them. So we work out both of those. 4C2 is 6, 6C2 is 15. So there is 90 ways. Now it says the probability. So we've worked out the number of ways of doing it this way. Now, in a previous part of the question, we'd worked out the total number of combinations. So the probability there is 90 over 675. The probability of this first scenario is that. Okay, so these first 2 asks us the number of ways of doing stuff. Part 3 asks us the actual probability, so we have to do out of the total number of ways. Now part B is, the second scenario is 2 boys from class A. So 2 boys, there's only 2 boys in class A, so 2C2 times 4C2, because there's 4 boys in the second one, we want to choose 2 of them. So that's going to be 1 multiplied by 6, which is there's 6 ways of doing that, which as a probability, so the probability of B is equal to 6 out of 675. And the total, so we can have it this way or this way, so we don't mind. So the probability of A or B is equal to 90 over 675, sorry, let's scroll down, plus 6, because we can do either way, equals 96 over 675. Okay? Now they simplify that in the book. If you type it into your calculator, 32 to 225. Okay, so if I just scroll back. Alright, there's the full first example. So if you take that down, and I'm just going to do the second example, a bit different to the way they've done it in the book. Okay, I'm going to look at the second example. Now they do it using combinations. So do have a look at it, understand it, read through it. In the bit here, the bit of reading here that you're going to do, it says that we can use combinations. We don't necessarily have to. So I'm going to do it the way I would personally. If I got this question in the exam, this is the way I would do it. But again, you can do. There's multiple ways to do this. It's not always just one right way with probability. Okay, 3 cards are drawn at random from a pack of 52. So again, if they give you a cards question in exam, I think they'll have to give you a bit of information because not everyone's familiar with cards anymore. So 52 playing cards. Find the probability that the 3 cards drawn are the Jack of Spades, the Queen of Clubs, and the King of Clubs. So I personally think I would say, instead of using combinations, I would say there's only one of those in the pack, there's one of those in the pack, and there's one of those in the pack. So there is 3 out of 52 for the first card, because we can have any of these 3 for the first card. Then once one of those is chosen, there's going to be 2 cards left, and there'll only be 51 cards left in the pack. And then for our last card, we'll have one of these left, and there'll be 50 cards. So the probability is 3 by 2 by 1, which is 6. 52 times 51 times 50 equals 1326000, and that simplifies down to 1 over 22100, and that's what they have in the book. Okay, so I would have done it that way, that we have three cards that we want. It doesn't matter which order. If it was in order now, we would do it a bit differently, but it doesn't matter which order we get them. So there's 3 chances of getting our card in the first one, and then 2 in the second, because we'll have chosen out one of ours, and then only 1 in the last one, and obviously we're removing and we're not replacing it. Okay, so that's the way. The 3 cards are aces. So the 3 cards are aces. How many aces are in a pack? 4. So on the first go, we have a 4 out of 52 chance of it happening. On the second go, we have a 3 out of 51 chance of getting an ace. And on our third go, we have a 2 out of 50 chance of getting it. So in this case, this works out to be 4 by 3 by 2. Okay, so we have 6 times 4 is 24 over 1326000, and that's equals 1 over 5, 5, 2, 5. And that's what they have in the book. Except they do it a bit differently. But again, I'm just showing you two ways. Okay? This is not using combinations, obviously. 2 reds and 1 club. So 2 reds and 1 club. So reds are half the pack. Okay, so the first 26 out of 52 times 25 out of 51 times clubs, there's 13 out of 50. So if we multiply those, 26 times 25 times 13 is equal to 8450 times by, we've been working this out before, 132600 divided by 132600, 13 over 204. Now you'll notice that's different than the answer in the book, because we've based that probability of probability red, red, club. But there could also be probability of red, club, red, or the probability of club, red, red. There's different ways, because we're not asked for a specific order. So you can just, because there's 3 different ways of doing that, you'd have the same probability. You'd just be adding 13 over 204 plus 13 over 204 plus 13 over 204. So we can just multiply that answer times by 3. So if we times that by 3, we get 13 over 68. And that's the answer they get in the book. And again, you can see how they did it using combinations, and it's fine to do either method. I'm just showing you a different method. Okay, right. Last one, probability the same color. Okay, so if we just scroll in there, probability the same color. So that's the probability of 3 black or 3 red. So the probability of black, black, black is 26 out of 52 times 25 out of 52 times 24 out of 52. And again, you don't have to work out top and bottom separately. I have been, but if you do 26 over 52 times by 25 over 51, oh sorry, these are meant to be 51, 50 because they're not being replaced, times by 24 over 50 equals 2 over 17. Because it doesn't matter, you want black or red, so you could have the probability of red, 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 which would be exactly the same, 26 over 52, so again 2 over 17, so you can just add those two or just multiply that by 2, so 2 over 17 plus 2 over 17 is 4 over 17. Okay, so that's the way just of doing it differently to the way that's in the book, so whichever way you want is absolutely fine. And again, just read the last one. It's something that we've talked about before. Events occurring at least once means the probability of E occurring is 1 minus E not occurring. Okay, so at least once, you just find out what's the probability of it not occurring and then take it from 1, instead of working out all the combinations of it happening at least once. Okay, so take down those 2 examples and I'll give you a couple of questions to try as well.